Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab. And if you scroll down and the search here, LRU Cache, you will find the problem number 146 and it's come under the medium category. And but it's an you can say it's easy, a little bit easy. But if you want very faster solution, then it will be little uh, medium. But it's not. I can't say it's like medium. Okay, so LRU means like least recently used. So what we have to do is we have to design a data structure that follow the constraints of the least recently used cache. Implement the LRU cache class. So there is a one class given and which we have three function givens: init function, get function, and the put function. And we need to implement all these three functions: init function, get function, and the pass put function. Right. So in the init function, we have to initialize the LRU cache with positive size capacity. So which is very easy. We have to just initialize like our capacity, whatever the capacity will be given, and we have to just initialize. And in the get function, get function, we have the key will be given, and we need to return its value. And if the key doesn't exist, then we have to return -1, which is also seems easy. Let's suppose, because if we have the dictionary and in the dictionary we store something and we want the key and the key doesn't exist, we can return the -1. So that looks also easy. In the put function, we need the key and the value, and we need to update the value of the key. So if the key exists, so basically if we have to insert something, if the key doesn't exist, then we will insert a new key. And if the key exists, then we will update the existing key. But the concept here is here is of the cache. So cache has some capacity. So let's suppose a cache has 4 capacity or 5 capacity, and all the capacity got filled, and some element come. So we have to check first if there is a capacity or not. If there is a not capacity, then we have to first remove the least recently used key. So that is a little bit you can say tricky part. We have to remove the first least recently used. That is the element which was inserted very old, or which not old, which has not even used. So that is the least recently used. Then we have to remove, then the space will be generated, and then we will insert. And one more thing we have to notice is the insert and the get function must be in the O of 1 average time complexity. So it should be in the O of like O of 1 operations. Either we do get, it should be O of 1, either we put, it should be like O of 1. There should be no like we don't need to run even a linear, just a constant time complexity. So first let's try to understand the LRU concept, how the like LRU works. All right, and after that like we will try to implement the logic. All right, so how the LRU concept like works is, so let's suppose we have some cache given. Let me show you. So LRU, we need to implement three function: init, get, post. And what is a cache? Cache, we know it's a kind of a storage which has some capacity and it is used for faster accessing. The full form of LRU is least recently used. And how does the LRU cache will work? Let's suppose we have so we have like some operation given. All right. So here is we have some cache given, and cache is of size 4 because some capacity constraint is there, because cache is not like unlimited. So some constraint is given. So let's suppose it's of size 4, right? Okay. So let's suppose the first operation is the put 1 of 100. So first what we have to do is like, if put 1 of 100 before inserting any value, we will check if the key exists in the cache or not. So key doesn't exist in the cache. I'm not telling you about the coding perspective. I am telling you about the normal perspective. Even though we will convert this into the code later on, first we understand, all right, what actually the question asks. So let's suppose someone perform the put operation. So in the put operation, what they will pass? They will pass the key and they will pass the value. So same thing they are passing. They will pass the key and they will pass the value. So key is 1, value is 100. So we will check whether this key exists or not, because if the key exists, then we are going to update the key, right? So but this time the key doesn't exist, And then again we will check if there is a capacity. Yes, there is a capacity. There is a capacity of 4. There is empty space 4. So we are going to insert. All right. So new will be inserted here and old will be inserted here. Or you can say new old will be here and whatever the new come here, we can insert here. Like it's up to you however you want to design. And both is perfectly fine. Now the some another operation will be from 2 of 100. All right. So we will check if is the key exist? No, is the does the key doesn't exist. Is there a capacity? Yes, we have the capacity of 3. Still, we can insert 3 more elements. Yes, we have the capacity of 3. Then we have to insert 2. But we can't insert 2 here. If we can insert 2 here, so we have to make this pointer as a new pointer. But what we said, like new pointer is this and old pointer is this. If you want to insert here, you can insert here in a kind of a dictionary. Whatever the latest element, that is the newest, because the concept is the least recently used. So we are inserting 2. So 2 is the most recently used. So in comparison to 2, 1 is the least recently used. So that's why we put 2 in front and 1 before. Or you can say, if you want to say like old this and new this, then you can just append here. It's up to us how you are going to design the logic. Based upon that, like we will perform the insert and the remove operation basis on that. If we are inserting at the last, then we are just like insert append. If we are like insert, we are considering new will be at the first, then we have to insert at the first. So it's up to us. So now get one. So someone perform the get operation. So for before like get one, so we will check whether the key exists. Yes, the key exists. Let's suppose if the key doesn't exist, then we are going to return -1. Now the key exists. So if the key exists, first we will remove this key and we will insert in the first step, because now 1 is the most recently used. So the cache concept is, let's suppose we have 5 files. Whatever the files, either it's any operation, by using any operation, we are accessing any file. So that file is the most recently used. All right. So if we are accessing 1, so 1 is the most recently used. So 1 should come first and the 2 will remain as it is. Okay, now insert 3. So whether 3 is there? No, 3 is not there. If we have, do we have the capacity? Yes, we have the capacity of 2. So we can insert. So we have inserted 3, but 3 should be inserted in front, because in the front we are considering a new hair or old hair, right? Or you can do vice versa. Okay, now someone will perform get 2. So first, before performing get operation, whether the key exists. Yes, the key exists. Then we will remove from here and insert at the top, and we are going to return its value 200. Then we are inserting 4. So whether the 4 is there? No. Whether we have the capacity? Yes, we have the capacity. So we are going to insert 4. So we are going to insert 4 in the front. All right, so we are going to insert 4 into front, because 4 is the most recently used and rest are the least recently used. Now we have to perform get 1. So 1 like is there. Yes, key is there. So we are going to delete this. So now 1 access. So if 1 access, then 1 is the most recently used. So 1 will become in the front. Right, now get 3. So is 3 exist? Yes, 3 exist. Yes, 3 exists. So we will remove the 3 and insert in the top, in the in the front position, because 3 is the most recently used. Now get 4. So does the key 4 exist? Yes, the key 4 exists. So we are going to remove the key 4, whole element 4, and we are going to insert 4 in front, because now 4 is the most recently used. Now we are performing the operation put 3000. So first we check whether 3 exists. Yes, 3 exists. So instead of inserting the new element, we are going to update its element. Right. So first we can do is we can remove the 3 from here. We can insert the 3 in the front, but with the latest value 3000. Okay. Okay, now get 10,000. So to perform the get 10,000, we will check whether the key 10,000 exists. No, key doesn't exist. So there is no such key. Then we are going to return -1, and the cache will remain as it is. Okay, then put 500. Okay, the key 5 exists. No, key 5 doesn't exist. So key 5 doesn't exist. All right. Is there any capacity? No, we don't have the capacity. So what we have to do is we have to remove the least recently used. which one is the least recently used. So this is the least recently used because 3 is the most recently used. After that, 4 is the most recently used. After that, 1 is the most recently used. So 2 is the least recently used. So we will remove from end, and then space will become, then we are going to insert in front. So 500, right? So that's it. So in this way, like we are, this is the like by considering all this operation, we have to design our logic. So we have like seen everything. So what all operation we need to perform considering all conditions. If we consider all condition, get put, whether we have the capacity, whether we don't have the capacity, what all operation we have to perform. So whenever there is an insert, so insert should be at the front, right? Insert should be at the front. Or if you consider new here, old here, then insert should be at the last. So it's up to us. If insert at the last, then remove from the end. If insert at first, then remove from the last, because last is the oldest one, and oldest one means least recently used, then we have to remove that. So what four operation or five, or what all operation we need to perform. So insert at left, and it should take O of one. All right, it should be take, because in the question it is mentioned, because both get and put means insert, and get means also like get. So both get and put must take O of one. Okay, fine. So insert should be at the left position. Insert should be at the left position, this left position. All right. Okay. Then delete from the last, because whenever we are deleting, we are deleting from the last, because last is the least recently used. Okay. And get operation should O1, and one more operation we want, that the length of the particular data structure, whatever the data structure we. So here I show in the form of a list, but whatever the data structure we want, we have to calculate the length, because when we have to insert any element, we have to calculate the length, and that length we have to check with the capacity. If there is no capacity, then we have to remove that. So we need to perform the length operation as well. Okay, so what data structure we can use? Can we use array? Can we use list? Can we use dictionary? What data structure we can use to implement our code? Because if you see get, push, put, post, these are very simple operations. The main thing is which data structure we can use to implement this. All right. So we can perform this question in multiple ways. So let's try the first way. So can we use the dictionary hash map? Let's suppose if you use the dictionary, right? So in the dictionary, we can insert in O of one, which is perfectly fine. We can delete in O of one, which is perfectly fine. We can get in O of one, which is perfectly fine. So all the operation can take in O of one, and we can also perform the length. But let's suppose you have the dictionary, like right, but how you are going to consider? So like you can consider, but let's suppose you have the dictionary. So first you insert one, then you insert two, then you have insert three, then you have insert four. So you can insert. So we know after Python 3.7, the dictionary maintains the order. But if you are running less than 3.7, then you have to use the ordered dictionary, because before 3.7, the dictionary stores the key in random values. Like you are inserting 4 at the end, but when you try to print the dictionary, it will come here. So but after Python 3.7, by default dictionary is maintaining the ordered in whatever the order we are inserting. Okay, that is fine. So if we have to delete, we have to delete from here. All right. So we have to delete from here, but how we are going to access the first element? All right. So the first way to access the first element is we have to like loop over the keys, and we will get the first key, and we can delete, because this is the oldest one. All right. So this is the first approach. Okay. So we can do that. All right. But a little bit like complications. We can't say, but even that is like easy only. We can delete the first element. All right. For get operation, dictionary is very best. If we use a list, that will going to take O of an operation. All right. If we use the queue, right, in the, what is the queue? Queue is a kind of a line in which whoever is the new person come, that will come at the end and remove from the front. But in our case, what we want, if any new person come, it should come at the first. It should come at the front. All right. right? So we can't use the list, because if we use the list, we can append, and we can consider this as a new. But to access the element, then we have to, you can say, or even if we have to delete this element, then we have to arrange everything. It is going to be more complicated, because if we remove any element, then there will be some space like in between the list, then we have to uh, shuffle all the elements. So list we can't use. So if we use queue, in the queue, this is the first element. So first in, first out. Whoever will the first, that will remove first. But this is not something which we want. We want whoever come last, that will going to remove first. All right. So queue we can't use. Can we use stack? Stack we also can't use, because okay, whoever, because in the stack, both insert and the delete come from the top. But this is not something we want. We want insert at the top but delete from the last. In the queue, insert at the end, delete from the top. So something not which we required. Can we use the DQ? DQ is the double-ended queue. So double-ended queue is in which we can perform the insert and delete operation from both ends. So yes, we can use the double-ended queue. So in the double-ended queue, we can insert from the end, we can delete from the front, we can insert at the end, we can remove from the. So basically, both insert and delete can be performed on the starting as well at the end, and it took O of one time complexity. So which is perfectly use case for us. All right. So because in the get, in the question it is mentioned we need to perform get and the put in the O1. All right. So and the DQ is a part of a Python collections module. So from the collections we can import the DQ. Right. So which is perfectly fine, and we have to do the same thing only, a kind of a DQ, double-ended queue. All right. If we have to insert, we will insert here. If we have to delete, we have to delete from here. All right. So what operations come here, like append, right? Append means append at the last, append right. Append left means in the starting. So if we consider a new hair or old hair, then we have to use append left. If we consider old hair and new hair, then we have to use only append, right? And so that is append. So let's consider these operations when we consider new hair and old hair. So to add any element in the form of put, we can use the append left. That is fine. But how you are going to remove the element? So for to removing the element, we have something called remove, or you can say, yeah, remove. So we can remove the element. We can directly remove the element particularly. Okay. And we have the, and we can calculate the length of the DQ as well. All right. So everything we can we can do from this. Okay. So let's but there is a one thing. Insert and delete is fine. Insert and delete is fine. Put is fine. Our thing is, but what about the get? Right. So let's suppose this is the queue. What about the get? So if I perform two, if I need to retrieve the two, I have to again scan the element, which we don't want. In the get operation, we want big O of one operation. So for the get, we have to use the dictionary only. So basically, in this question, we can use the two data structure. We can solve this question by using one data structure as well, but let's do with the two data structure. Then we can go try to optimize it even more. So if we use dictionary and the DQ both, then our solution will be implemented, because in the dictionary we are going to store the key and value, and in the DQ we are only going to store the keys like 1 2 2 3, right? So let's try to implement it. So first we have to import from collections, import DQ, right? We have to use the init, like we have to define the init function. So self dot capacity is equal to capacity, and we are like, which data structure we are using? We are using the dictionary hash map, you can say, so that we can perform the get operation in a single run, and we can use the dequeue dequeue because insert and delete can be done from the both the ends. Right, so that's why we are using the dequeue, so that is fine. So init operation is done, perfectly done. What about the get? So whenever the get operation is done, we have to perform. So what we are checking? We are checking whether the key exists or not. So, and we know the get operation should take O of 1. And we are inserting the key value in hash map as well. So we will check in the hash map. So if key in self dot hash map, if it is there, then it is fine. Else we are returning -1, because if the key doesn't exist, we have to return -1. Right, but if key exists, right, so in whenever we perform get, so let's suppose this is the cache and we have to perform get. So whenever the key exists, it doesn't mean we are only just returning its value. If we have to return the value, we can just return the we can use the dictionary only. But this is the least recently used, so we have to remove from here and we have to insert in starting. So basically, uh, if key in self dot hash map, so if it is in hash map, so value is equal to self dot hash map of key. So this is something which we have to return value. So, but is this the only thing which we want to do? No. If it, because now one is the most recently used, but if we left one here, then it will become the least recently used. So we have to remove from here and we have to insert in the dequeue. So what we have to do is, so self dot cache dot remove dot key. So we will remove, and where we have to insert cache dot append left. So we are going to append in the left only, right? Because in the dequeue we can insert in like, or if you are considering new here, old here, then you can use only like append. Okay, so that is so our get operation is done. What about the put? So whenever we have to put here, so first we check whether the key already exists or not. So if key in self dot hash map, if it is there, then we have to do something. Else we have to do something. If it is there, then we don't need to check the size because the key already there. All right. So if key already there, what we have to do? All right. Let's suppose where so in case of 3, so this is the cache. All right, now we have to insert 3000. What we have to do is, first we will remove the key from the cache. So how to remove? Self dot cache dot remove, we can remove the key. All right, and we can remove the key, and we are going to insert append left, because we have to append in the starting, and in the do queue we have the operation append left. Append left. All right, so we have to self dot cache append left, and we have to insert the key. Along with that, we have to update the dictionary. Self dot hash map key, we are updating the dictionary as well. So that is perfectly fine. If the key doesn't exist, then before inserting the key, we are going to check the capacity, whether there is a capacity or not. So if length of self dot, or either you can we can do the self dot cache, because we will check the length of the cache, or you can check the length of the dictionary. It's like both are the same thing. Equal to capacity, or you can say less than capacity. Then we have to do something else. We have to do something. If length is less than capacity, it means we have some space. All right, we have some space. So what we can do is we can just append at the left position. Along with that, we can insert the value into the dictionary because that is the new key that doesn't exist. Otherwise, what we have to do, if there is no capacity, like in our case there is no capacity, then what we have to do, we have to delete from the last, right? So to delete from the last, so we have the pop operation, the pop operation, all right? If we have to delete from the first, then we have the pop left. So if we have to delete from the last, then self dot cache dot pop. We will remove the last element because that is the least recently used, along with the, so now we are, because now there is a space, so we are inserting, and then we are uh, inserting into the hash map as well, right? So that looks okay to me. So let's try to run it. So capacity is not defined, so it should be self dot capacity. Okay, 2 is not in the DQ. So there is some error. So let's try to figure it out why it's there error. So we are performing the get operation. So if key in self dot hash map, if key in the hash map, then it means key should exist in the cache as well. So is this the remove operation or something else? Okay, remove first occurrence of the value mentioned in the arguments. Yeah, first occurrence of the three. So which is fine. Self dot cache dot remove, and we are going to remove key. And what is the error? 2 is not in the DQ. Okay, function is correct, but it is saying it is not in the DQ. We have not deleted the. So let me figure it out, like why it is failing. So this is correct, but the error is here. So when there is no capacity, right? So we were only removing the key. So I missed this line. I just added this line. So I was removing the key only from the cache, but we are inserting at two places, in the cache and as well as the hash map. So if there is an old least recently used and its capacity and we are removing, so we have to remove from the hash map. So that's why I have to remove it from the hash map. So that's it. And if I try to run it, and now it's accepted, so let's try to submit it. So our solution has been accepted by the Leetcode, but if you notice, we have beat only 6% of the people, which is very bad, right? So even though it's accepted and solution is perfectly correct, but uh, like, can we improve this solution? So definitely yes, we can improve this solution. So what is the other way? So the other way, which I already told you, is we can only use the dictionary. We don't even use the DQ, because in the dictionary, whatever the latest element will insert here, and whatever the oldest element, it will remove from here. So we are not going to use the Q. So let's remove Q. We are only going to use the dictionary here. So let's remove this. So we let me write the coding. Let me write the logic from start. So what we have to do is we will only use the hash map. So if there is only dictionary, we will use. If key in hash map, yes, key in the hash map. So what we are going to do is we are going to return the value, right? But in the dictionary, so let's pause, because we have to use the logic of least recently used as well. So let's pause. Uh, there is a dictionary. So in the starting, dictionary is empty, right? So first one will come, then two will come, then three will come, then four will come. So four is the latest element. Now we want the get two. So if we want two, so now two is the latest element. So how I am going to put two here? So to put two here, what I can do is I can delete two and I can insert, because whatever the new element is going to be inserted into the dictionary, that will become the latest element, because from Python 3.7, it will maintain the order. All right. Even if you are using the Python 3.6, then you can use the order dictionary. So what I can do is I can just remove this two and I can insert at the end. So what I can do is I don't need the cache. What I can do is I can remove the hash map HASH, because let me delete close this. So I can, like, let's suppose I am like accessing two. So now two is the latest one, so two should become at the end, because at the end the latest element will become here, that is the most recently used. So I will remove two here and it will become, I will add two in the front. That's why, like, I don't need to use the like DQ. So that's why I delete this and I have to insert this again. Q is equal to value, whatever the value is, the old value is, because we are only like inserting it. All right. Okay. So dictionary will be done. What about the put operation? So in the put operation, so if key in self dot hash map, if key is already there, so we don't need to use the cache. So let's remove this. So if key already there, so let's suppose we are putting the three. So if key already there, all right. So first thing is we can just remove it and we can insert it with the latest value. That's it. So first we can do it, we can remove it self dot hash, because we can't only update, because we want to make it the most recently used. So that's why I will put at the end only. So self dot hash map. So we are going to delete it and then I am going to update it. That's it. Self dot hash map dot key is the value. Okay. If key, that is the key in, if key not in, then I'm going to check the size of the hash map, right? Because there is no cache concept. So let's suppose four elements already there. Now I need to insert the fifth one, but the capacity is four. So what I have to do is first I will check the size, capacity of the dictionary. If the capacity of the dictionary is less, so it means there is still some space. All right. If there is still some space, I am just going to insert the value. That's it. Because whatever the value will be inserted, it will is going to insert at the end. At the end means the latest one in the form of a dictionary. So that's fine. But if if there is no capacity, if there is no capacity, then what we have to do? If there is no capacity, then we have to delete the one from here, and one is the like you can say uh, least recently used element. So how are we are going to access the first element of the dictionary? All right. So we have to like we have to we have to insert here like this only. So this value will become as it is. We just need to delete the one element. That's it. So we don't need this cache. We don't need this. So we have to delete the first element. How we are going to delete the first element? So to access the, like, in the Python function, there are a iter method, iter Python. So what iter will do is iter will create any object in the form of an iteration. So let's suppose we have the list and we have to access all elements one by one. What is the approach? One approach is like using the for loop. If we convert into iterator, we can just put iter function, it will become iterator. And if we use the next function, then we are going to insert, like we are going to access first element. Then if we are going to use again next, then we are going to access the next element. If we are going to again next, then we are going to access the next element. But in our case, we have to access only first element. So only this part is enough for us, iter and the next. So what we can do is, or even like this is a little bit tricky because iter and next, if someone don't know, then it will be a little bit tricky. We have the some other approach as well which everyone knows. So let's try with this approach. So what we have to do is, we have to convert first self dot hash map into iterator, right? Then we have to access the first element using the next. So if there is a first element, then we have to delete self dot hash map, and that's it. Then we are deleting it. So let's try to run it. So accept it and try to submit it. So this time you could see we have beat 94 or approximately 95% of the people. When using the DQ, our solution is submitted, but we are beat only 6% or 7% of the people. But using the hash map, we if we use only dictionary, and we just a little bit kind of a logic, because we know like we can within the dictionary, after 3.7 it maintain the ordered, and whatever the new element it will come last. So if there is a this element we want to access, we will delete it and insert at the last, because we want to make it the latest element. Right, so we just this kind of a like a logic, and we have inserted it. So we have beat approximately 97, 95 or 96% of the people. And let's suppose you think it's a little bit tricky part, you can't do iter next all these things. So I am definitely sure you know how to access the keys, because we want to delete the one which is the oldest element and the least recently used. So how you are going to access the keys? So self dot hash map dot keys. So you are going to access the keys in the form of this, and you can convert the keys into the list. And if you convert the into the list, then you are going to access the first element. So you can say the oldest key is this, and then you can just delete the oldest key. So you can run it. So accept it. So let's try to submit it. But here we beat only 16% of the people. Still better than the DQ, because in the DQ we are only beating 7% of the people. If we use iter is very fast, because in the list now again we are converting into the list, and so many things. All right, so it is going to access all the elements, and uh, because it's 10 to power 4, so it is taking going to till and and converting into the list. So it is taking some time, because if we only use iterator, it is just creating the iterator. We are not accessing all element, and we are picking the first element. That's why we beat 95% of the people. But you can do this as well, like which is also like easy approach. If iter and the next concept will not come into your mind, and let's put the DQ concept also not come into your mind, then you can go ahead with the dictionary only, and with this approach as well. So but the first approach, like which we did the DQ, we should know all the approaches, because the collection modules is also very important, the DQ module. Then we use the hash map and iter and the next, then we can try with the this operation. So that's it at the end of the video, and thank you. You can also try the same question.